Hello and welcome to Train Signal. You're watching video number 12, Networking in Linux Part 1. This is part of Fast Track CBT Video, Linux Networking and Administration. So in this video we're going to talk about configuring client TCP/IP settings in Linux, configure basic network server features, implement basic routing and subnetting, and troubleshoot networking and hostname resolution problems. So Linux Plus Objective 3.1 says you should be able to configure client network services and settings, for example, settings for TCP/IP. Well, I think that one's pretty obvious. Really every computer today uses TCP/IP. So if you're configuring network services and settings, they're going to be related to TCP/IP. Now most computers today also connect to a LAN, a local area network, that's your local network, using Ethernet. So Ethernet is the layer 2 protocol or data link protocol on the OSI model. Let's scroll down here and look at the OSI model. This is the OSI model for those of you who aren't familiar with it or haven't seen it in a while. It's a 7-layer, it's a theoretical model, and so protocols and cabling and different applications and methods of processing network traffic match up with these different layers. So down here at the physical layer is your cabling. This is where your hub is, your Ethernet cable. Here at the data link layer is Ethernet and Ethernet switches. So Ethernet is what's connecting local area network devices. Now if you go out across the WAN or a wide area network like the Internet, you're going to have your Ethernet, your data link traffic encapsulated in some other protocol, some other layer 2 protocol. But on the LAN, you're just using Ethernet, no other data link protocol. So if we scroll back up here, I want to point out that every Ethernet device has a MAC address that uniquely identifies it. So just like every person in the United States has a social security number that identifies them uniquely, so does every Ethernet device in the world. Now, up one layer from the OSI model is layer 3, or the network layer, and that's where the IP protocol is. So if we scroll down here, you can see here's the IP protocol, and here above it is layer 4, or transport, and that's where the TCP protocol is. So if you combine these two, you see TCP and IP working together. It's not just one application or protocol. So now all Fedora network communications is done with IP. Every IP device has an IP address and a subnet mask. Now this IP address should be unique on your LAN, but thanks to network address translation, it's probably not unique in the world like an Ethernet MAC address is. So chances are on your internal network you're using private IP addressing, and to get out to the Internet you're using public IP addressing. And your private IP address is translated into a public IP address, because every IP address on the Internet does have to be unique, because those are all public IP addresses and talking to one another. And if they were the same, they would have confusion on as who's who. If you're trying to talk to people and they both have the same name, it gets confusing. Well, same thing with having unique IP addresses. So you can obtain your IP address by assigning it to yourself statically or receiving it from a DHCP server on the network dynamically. So with static, you're typing it in yourself. It's not going to change. With dynamic, you're receiving it from a DHCP server, and chances are it will change at some point. Now, an important network configuration file is right here, etc sysconfig network-scripts /ifconfig-ethernet0. Wow, that's a mouthful. But most command line IP address changing is done with ifconfig, ifconfig. This is like ipconfig, except it can do more. It can do more than the Windows ipconfig. Or you can use the graphical tool from Fedora Linux, which is system config network. Now, besides having an IP address and a subnet mask, most devices also have a default gateway so they can get out of their own network. The default gateway points to a local router that has access to other networks like the Internet. So without a default gateway, or a gateway as it's just sometimes called, you can access things on your local LAN, but not on the WAN and not out on the internet. Now, most people don't just use IP addresses to connect to other hosts. Instead, they want to use names, right? You don't want to just connect to 5.10.49.68. You want to connect to www.trainsignal.com. Now, that's great, but there must be some way to match up these host names with IP addresses. One way to do this is statically with a text file on your server called etc hosts. This is where you can go in and manually type these in. But can you imagine trying to keep this updated for every host on the internet? It would be impossible. So that's what DNS does for you. Dynamic domain name system. So DNS can keep track of all these things, and there's even dynamic DNS to keep track of hosts as they come on and get off the network. So chances are to access the internet, you're using DNS, domain name server, and DNS is actually hosted by your internet service provider many times. So you're actually going out to the internet service provider, to their DNS servers, finding out the IP address that matches the host name you're looking up. So to do this, you can either configure your DNS server IP addresses manually, or you can receive those through DHCP as well. So with that, let's go out and take a look at the different command line and GUI tools used to configure IP addressing in Linux. Alright, here we are on our Linux server. So first let's start up the GUI tool. Let me show you that tool. If I go to System, Administration, and Network right here, click on that, and it brings up this pretty nice little GUI tool. So here it shows me my active Ethernet interface. It's called Ethernet 0. It's an Ethernet interface that's active. I can click here to deactivate it or reactivate it. I can click here to edit it. By editing it, I get to name it, and I also get to choose how I want to set the IP address. So I have obtain IP address settings with DHCP, BootP, or dial-up, or statically set the IP address. So this is where I was talking about. You would just type in your IP address, your subnet mask, your default gateway. Now your DNS settings are set on a different tab. We're using DHCP because we have a DHCP server on the network, and we're automatically obtaining DNS IP addresses from our DHCP server. If I click over here on routes, here's where I can manually add my own routes, add or remove routes. And then on a hardware device, here's where my MAC address is. So if I click cancel, we can go through these tabs here that say hardware. We have an AMD network interface card. There's IPsec for IP security. We don't have that configured. And then there's DNS. So this is where you put your DNS host name here, and this is where you put your DNS search path. So if you just type in client 12, it's going to actually look up client12.bigskyfishingsupply.com. And then here's where you put in your DNS server IP address. So this information here was obtained actually dynamically through DHCP. Then finally, here's the host tab, and you can manually add hosts. This is really just editing the etc host file. But if you're using DNS, you shouldn't have to go in here and use the host file. So this is the GUI tool, and it's called System Config Network. Comes with Fedora Linux. So if I close this out, we're back here at the command prompt. The other important command is ifconfig or ifconfig. If I just type it by itself and press enter, I get my two different network interfaces. If I press up arrow and I specify that I want the Ethernet 0 interface only and press enter, I get just that interface. You can see from here, I can see my hardware address or my MAC address, my IP address, my subnet mask, right there, that this interface is up and running. It's received 157 packets, it's transmitted 83, and it looks good from here. So other things I can do with this command are I can down the interface, or I can up the interface. I can also specify a static IP address, and I can specify my subnet mask, like that if I wanted to. I can add a default gateway. Like that if I wanted to. So I can add a default gateway. There's a number of other things I can do with the ifconfig command. I'd recommend reading the man page to familiarize yourself with it. A couple other important commands at the command line are route. This shows you your routing table. So notice here I have a default route to this IP address. This is my default gateway or default route. So if it's not on my local area network, I send it to this IP address. You can also use the netstat -r command. There we go, netstat -r. Notice the output's exactly the same. It does the exact same thing. We were talking about the etc host file. If I cat that out, cat etc host, you can see here I don't have any hosts defined other than my local host adapter, which is 127.0.0.1. I could go in there and VI that file and manually edit hosts if I want. Another important file is etc ns switch.conf. This file tells DNS on my local client here what to do with hostname lookups. And first it says to send it to files. That's what this line is right here. The most important part of this whole file here is this line that says for host lookup, first send it to files, and the file is etc host, and then send it to DNS. So first it looks in the etc host file. If it's not there, then it sends it to DNS. So if DNS wasn't here, you would never go out and look up host names on the DNS server. So that's how basic IP address configuration works on a Linux server. Let's close this out. Go back to our slides here. Okay, so we learned about configuring client network services and settings, and setting our IP address using ifconfig and systemconfig network, as well as other IP settings. So now let's go on to our next section. So now we're going to talk about basic network server features. Linux Plus Objective 3.2 says configure basic server network services from a client perspective. Now that's pretty broad, but what we can speculate is that they want us to be able to configure common things that remote clients would be requesting. And in some upcoming videos, we're going to be configuring things like FTP server, HTTP server, the web server, and Samba. So those are some common network services. In this section, we're going to just kind of go over this in general, how these services are started and what controls them. So most Linux network services are run from a super server. This service is the parent of all other network services. Now, you can always choose to run services not as children of the super server. So I could start FTP daemon or the FTP server just by itself if I wanted to under its own PID. Or I could choose to run it under one of these super servers as a child of that super server. There are benefits to running it under the super server, such as you get greater control. You get a single point of configuration, so I can go to one screen and see all the different services I'm running. Start them, stop them, whatever I want to do. And there's less overhead. There's not a bunch of PIDs out there on their own. They're all controlled by one parent PID. Now in the past, inetd was the primary super server in use on Linux. Today, xinetd that's how they pronounce this with an X, xinetd or xinetd is predominantly used. The configuration file for inetd is at etc.inetd.conf, and the configuration for xinetd is actually a directory called xinetd.conf, and underneath that directory are scripts that are run for the different services, whichever ones you want to be started and stopped by the xinetd server. Now the Fedora GUI Services Manager application is called System Config Services. So from that application, it's kind of like the Services Manager in Windows. You can go in and start and stop services. You can also mark them to be disabled or to automatically start up when the server starts. Some common services you would enable might be like HTTPD for web services, FTPD for file transfers, Telnetd for command line telnet access, SSHD, which is already enabled by default actually, for secure shell, and others. Now Fedora Core 5 does not have either inetd or xinetd running by default. All new network services are the children of inet, which is PID1. So let's go take a look at how this works. So first off, let's go into the System tab up here, go to Administration, and then go to Services. If I maximize this, you can see on the left here, here's all the different background services that it can configure. So the ones with the little checks next to them are started by default. And if I select one, I can choose to stop it, start it, or restart it. And the little check means that at this run level 5, these services are going to start automatically when the system boots. So say I go to HTTPD, I can click on it and say start. It says it was started successfully, and it gives me the PID number for it. So if I go and I open a telnet window, or a terminal window, and I do ps-ef and I grep for HTTPD, you can see it's actually running as PID number 3009, and it's a child of the inet process. And it actually spawned a lot of other HTTPD services, and these are just here to handle multiple requests. So this is the services configuration program for Fedora Linux. There's also on-demand services over here, and it says that these services are started on demand and end when there's nothing more to do. The xinetd service must be running so that they can be used. So that's the services configuration program. If I close this out, and let's cd into etc, then cd into xinetd.conf or xinetd.d. If I do an ls-l, here's the things configured to run under xinetd, but xinetd is not started by default. So I can grep inet, and I don't find either inetd or xinetd. So that's how you configure basic network services to make sure that they're running so the clients can connect to them. And like I said, we're going to cover a lot of different network services in some upcoming videos as far as how those specific services are started, how they're configured and managed. So with that, we'll move on. Now let's talk about Linux Plus Objective 3.3. Implement basic routing and subnetting. And it says, for example, the sbin route command and the IP forward statement. Now routing is when two networks are connected together, two different IP networks. This is commonly done on a WAN or a wide area network, but it's only needed on a LAN when the LAN traffic grows. Now when you take one network and you break it into multiple networks, that's called subnetting. So you're taking one network and making it into subnetworks. To connect those two subnetworks, you need a router. To connect any network, you need a router. So when your LAN traffic grows beyond, say, 200 devices, or you start to get a lot of broadcast traffic, you really need to take that network and subnet it down into two smaller networks and put a router in between it, because a router would stop the broadcasts that are happening from either your broadcast traffic or just from having so many devices. Now, a Linux system can function as a router, but typically it would only be a LAN router because a PC server usually doesn't have the WAN interfaces for it to be a WAN router. So on a LAN you're using Ethernet. Well, it's cheap and it's easy to put a couple more Ethernet cards in a PC server and make it a router. However, it's very expensive to put a T1 interface card right in the back of a PC. It can be done, but typically it costs even more than just going out and buying a router. So most people just buy a dedicated router, and that way there's less overhead and less worry about an operating system like Linux when you just have a little box and that's all it does is routing. So most people go out and buy a Cisco router or whatever brand they choose. Now, routing local traffic to other routers is easily configured and allowed by default. So when I say local traffic, I'm talking about traffic on the Linux server or on the Linux workstation. So you can use the route statement if you know you have one router on your network that goes to one network and another router on the network that goes to another network. You can manually type in routes using the route statement. Most people don't do that, but it's possible. Now, to see the routing table, you would use netstat-r or the route command. Routing traffic through the Linux server that has two NIC cards must be enabled. So if you really want to use your Linux server as a router for your local area network, you would get a second NIC card and you go in and enable a special feature. And that way your Linux server could actually transmit traffic through it that's going to other networks. To enable this, it's called IP forwarding, by the way, and you use the syscontrol program, or you add a 1 to this file right here. So let's go take a look at how this works. So over here on our Linux server, there's a few different routing commands. One is, of course, route. Route shows you the routing table, your default gateway, and any other routes you have defined. You can use route space add or route space delete to remove routes. You can also use the network tool up here, the network administration configuration tool right here to add and remove routes. Of course, there's netstat-r, and it gives you the same output. And then to enable IP forwarding or routing through this server, if you have two network interface cards and you're going to use this server as a router, you cd to /proc/sys/net/ipv4. And if I cat out IP_forward, there's the file right there. Right now it's a 0. That means IP forwarding or routing is off. If I do echo 1 and I redirect that to IP forward, I just changed it to a 1. So that's how you enable routing right there. Let me go ahead and put this back. I don't want to be a router right now, but that's how it works. So I hope you get the idea of how routing works on a Linux system. So we completed our section on basic routing and subnetting. Let's move on to our next section. Now we're going to talk about troubleshooting network and hostname resolution problems. But first off, let's talk about some common Ethernet problems. So these are layer 2 Ethernet problems, and some of them are also actually layer 1 physical problems. So first off, you got a bad cable. You know, you're having trouble with connectivity to the network. Hey, check your cable. You could also have a bad NIC, a bad network interface card. And if you have no link light on either the network interface card or the switch or hub that the Ethernet cable goes to, you know something's wrong here. Could be the cable, could be the NIC, or could be the link. Somewhere in that link, right? The cable, the NIC, could be the switch port even, or the hub port. You never know. Many times, though, it's the cable. Now, something else to know is the NIC may not be activated or enabled. I showed you on the network configuration tool, the graphical tool there, you can click on the NIC and type activate or deactivate. Well, sometimes it's deactivated. You need to make sure it's activated. So my suggestions to any Ethernet or physical layer problems are to check it and see if the interface is activated. Check the link light on the switch and the hub. If you don't have a link light, you know it must be a cable, a NIC, or a switch or hub port. So some common problems with the IP protocol. First off, it says no IP address because no DHCP and no static IP is configured. So if you don't have an IP address, you're never going to be able to communicate on the network. A lot of people are used to getting DHCP and they just turn on their workstation and expect to get a DHCP address. Usually they do and it works. But other times they don't and they don't understand why. Or you configure a static IP address and you move your PC from one network to another network and you forget you need to reconfigure your static IP address. Another problem is incorrect IP or subnet configured. So say you configure a static IP address. You may have mistyped the subnet mask or mistyped the IP address, or maybe you got DHCP and your server is somehow giving out the wrong block of IP addresses. Another problem is you cannot ping the default gateway. This is a big one. I mean, if you can't ping the default gateway, probably you have a connectivity problem with a cable, a link light, or you don't have an IP address. Because if you can't ping the default gateway, you're not getting very far out onto the network or even across your local LAN. Now, my suggestions would be to always ping the default gateway and other hosts on the network and see what kind of results you get. Verify your IP address information. Make sure it's right. Use traceroute and use netstat to check and see if your firewall, check and see if your firewall is interfering with your traffic. Don't forget that you have a firewall in Linux, just like in Windows Service Pack 2, Windows XP Service Pack 2, you have a firewall. Well, same thing in Linux, you have a firewall. So if you're trying to run a web server and you didn't open up HTTP port 80 through the firewall, your clients are never going to get in. So keep that in mind. Then some common hostname resolution problems. This would be mapping your name, like www.trainsignal.com, to an IP address. Well, a common problem might be you're not using DNS. Maybe you don't have DNS servers configured in the DNS server list. Maybe you're using the etc host file and you don't have a host entry. Or maybe you're trying to go to a DNS server and that DNS server doesn't have a host name for the host name you're looking for. Make sure you can ping the DNS servers. If you can't ping the DNS servers, you're never going to get a DNS response from them. So that's a major problem. That could point to some of these other problems. And you can always use NSLOOKUP and DIG. These are tools that go to the name server directly and look up the host name that you're requesting information on, or usually requesting an IP address on, and these tools will query that DNS server and give you back a response. So this is the end of video number 12. We talked about configuring client TCP/IP settings. We talked about the IP address, subnet mask, default gateway, DNS servers, manually configuring that versus static. We talked about basic network server features like iNetD and ZyNetD. We talked about implementing basic routing and subnetting and how you have to enable IP forwarding. And finally, troubleshooting network and hostname resolution problems. We talked about layer 2 Ethernet problems, cable problems. We talked about IP address problems, incorrect IP address, wrong subnet, wrong network, no DNS server IP addresses in your configuration, can't ping your default gateway, can't ping your DNS servers. Use some of the other additional tools, traceroute, netstat, DIG, and NSLOOKUP. So with that, this is the end of video number 12. Thank you very much.